Hey, if you're a Java developer, you've definitely had that moment. You finish writing your code and you ask yourself, now what? Well, today we're diving into the answer that millions of developers have landed on: Amazon Web Services.
Right? So you've poured all those hours into crafting the perfect Java application. It runs like a dream on your machine, but then comes the big question. Where does it go from here? How do you actually get it out into the world so people can use it? And more importantly, how do you make sure it doesn't fall over when they do?
For so many of us, the answer is AWS. Now, at its heart, Amazon Web Services is this huge global cloud platform. But don't think of it as just one thing. It's really a massive collection of over 200 different services, covering everything from basic computing power and file storage all the way to super complex machine learning and data analytics. And look, when we say it's a leader, that's not just talk. The numbers really back it up. In early 2024, AWS held almost a third of the entire global cloud market. That kind of dominance means it's a platform that's been battle-tested, it's trusted by huge companies, and it's something you really need to get your head around.
So here's our game plan for today. We're going to look at the specific advantages for Java on AWS, check out the essential toolkit you'll need, walk through the journey from your code to the cloud, and then wrap up with the key takeaways.
Let's kick things off with the Java advantage and really dig into why AWS is such a fantastic home for your applications.
All right, first up, and this is a huge one: scalability. Just imagine your app suddenly gets a shout-out on a popular blog. With AWS, you can handle that massive surge in traffic without your app even breaking a sweat. And just as important, you can scale right back down when things get quiet again, so you're not paying for power you don't need.
So how does that magic actually work? Well, you've got EC2, which are basically your virtual servers. Then you have auto-scaling, which is the brains of the operation. It automatically adds or removes servers depending on how much traffic you're getting. And to top it off, elastic load balancing acts like a traffic cop, making sure all those users are spread out evenly so no single server gets overwhelmed. This is a game changer for Java microservices because each little service can scale up or down all on its own.
Next up, let's talk about something that's on everyone's mind: cost. Instead of buying a bunch of expensive physical hardware that just sits there, the cloud lets you rent exactly what you need, when you need it.
The best part is, you're not locked into these massive upfront costs. With the pay-as-you-go model, you only pay for the compute power you're actually using. It gets even better with serverless tools like AWS Lambda. With Lambda, you don't pay for idle servers at all, a move that can seriously slash your infrastructure costs, sometimes by up to 70%. Plus, when you use managed services for things like your database, you're not paying your team to do all that boring routine maintenance.
Okay, so it scales and it's cost-effective. But here's the real question for us: does it actually work well with the Java tools we already know and love? The answer is a resounding yes. It's designed to feel familiar, not like you have to learn everything from scratch. AWS gives you a software development kit, an SDK, built specifically for Java. This means you can control all those powerful AWS services using the kind of Java code you're used to writing, right inside your application. It also plays really nicely with the frameworks you're probably already using, like Spring Boot, and build tools like Maven or Gradle. That means way less time learning new stuff and way more time actually building cool features.
And then, of course, we have to talk about security. This is totally non-negotiable for any professional application.
AWS gives you security in layers. It all starts with something called IAM, which is basically the bouncer for your application. It lets you control exactly who or what can access your resources. All your data can be encrypted, both when it's just sitting there and when it's moving across the internet. And super importantly, AWS is compliant with major global standards like GDPR, which is a huge deal if you're handling sensitive user data. Okay, so we've covered the why. Now let's get into the what. With over 200 services, it can feel a little overwhelming, but for most Java developers, it really boils down to a core set of tools. Let's break this toolkit down, because picking the right tool for the job is everything. For compute, that's where your code actually runs. You could use EC2 for a classic virtual server where you have total control. Or you might go serverless with Lambda, where you just upload your Java function and AWS handles all the server stuff for you. It's awesome for small, event-driven tasks. For databases, RDS is your go-to for managed relational databases like Postgres. But if you need a super fast, flexible NoSQL database, you'll probably look at DynamoDB. When it comes to storage, S3 is like an infinite file cabinet in the cloud, perfect for things like user profile pictures or website assets.
That's different from EBS, which is more like a dedicated hard drive for your EC2 server. And finally, developer tools like the Java SDK we mentioned and Code Pipeline are the glue that ties it all together, helping you automate how you build and deploy your app.
So you've got the tools, you get the benefits. Now for the most important part. How do we actually get our code from our laptop into the cloud? Let's walk through a really common path and cover some absolutely crucial best practices. One of the easiest ways to get started is with a service called Elastic Beanstalk. It's designed to hide a lot of the underlying complexity. You literally just package your Java app into a standard .jar or WAR file, upload it, and Beanstalk does all the heavy lifting, setting up the servers, the load balancers, everything you need to get it running. It's a fantastic way to get your feet wet.
Okay, now for some best practices. And please listen up, because this first one is a big deal. Never, ever, ever hard code your secret keys or passwords in your application code. I'm serious. Instead, use IAM roles. This lets you give your application temporary, secure permission to talk to other AWS services without ever putting a password in your code. It's a fundamental practice for secure development.
You can't fix what you can't see. Think of AWS CloudWatch as the eyes and ears for your application. It gathers all your logs, key metrics like CPU usage, and performance data. You absolutely need to set up alarms here so you get notified the second something looks wrong. That way, you can jump on problems before your users even have a clue.
And finally, automate everything you possibly can. A CI/CD pipeline, that's continuous integration and continuous deployment, is basically an automated assembly line for your code. Services like AWS Code Pipeline can automatically grab your latest code, run all your tests, build it, and deploy to production, which dramatically cuts down on the chance of human error.
Whew. Okay, we have covered a ton of ground, so let's zoom out for a second and bring it all together into the most important points to remember.
So let's wrap this up. AWS isn't just a place to park your Java app. It's a whole ecosystem designed to help you grow, keep your costs in check, and seamlessly plug into the tools you already use. When you pick the right services for the job and really stick to the best practices for security, monitoring, and automation, well, that's how you take a project from your local machine and turn it into a global, production-ready application.
We've seen the what, we've seen the why. AWS puts this incredible amount of power and infrastructure right at your fingertips, the kind of tools that just a few years ago were only available to the biggest corporations on the planet. So the real question isn't whether you can build your next big idea, it's what are you going to build with it?